Hey guys, good morning. It is April 9th. This is Ms. Swack. Let's get into our learning. For today, we are going to use the values in a ratio table to create a graph on a coordinate plane. So we're going to have to dig deep and use that prior knowledge that we learned from units 2 and 3 about ratio tables to help us make sense of how to graph them. Okay, really the purpose of graphing them is to have a visual representation of the relationship between these two quantities that are in our ratio table. To help yourself as a student, best thing you can do, take some notes. We did not give you guys the pages from this particular unit before we left. So that means that to make sure you're engaged, to make sure you're understanding, you've got to take some notes about the important learnings and things that you want to remember after this lesson is over. To be successful, you know you will be successful when you can create a ratio table that shows the relationship between the two quantities. So I'll remind you of how to do that. We'll talk about creating ordered pairs from that ratio table, and we'll talk about how to graph those ordered pairs in your coordinate plane. Okay, just as a very, very, very quick reminder of what you have learned so far this week. Up until now, we've only worked in quadrant number 1. Today, we are going to be adding to that the other quadrant. So like this is quadrant 2, this is quadrant 3, and then this is quadrant 4. So we're going to be working with the other quadrants and really paying attention to our X and our Y axis. Please remember your X axis is this vertical axis. The origin is here in the middle, and then positive numbers are to the right of the origin, negative numbers are to the left of the origin. Your y-axis is your vertical axis. Positive numbers are above the origin, negative numbers are below the origin. Okay? To plot those points, you have to pay attention to what are the x and the y values, and how can I show that? If I am trying to figure out what point C is, that means I have to think about what are my x and my y values for point C. We're going to create our ordered pairs with those parentheses, and then your x value always goes first, y value always goes second. So for point C, right there, I'm going to go to my x-axis. That means that I'm trying to find that vertical axis, and I see that it's at -5. And then for my y-axis, I go over to the vertical, and I see that, it's at -3. So point C is at -5, 3. With what we're going to be doing today, we are going to be taking a ratio table, just like the one that you see on there, and situations, just like the one that we're about to look at, and we're going to graph that information. Okay, let's get started. It says, Lynn needs to mix a specific shade of orange paint for the set of the school play. The color she uses, 3 parts yellow and 2 for every 2 parts red. Okay, so if we look at our ratio table here, you'll see cups of paint has that 2 cups, just like what was in the description, 2 cups of red, 3 cups of yellow. That is what we call our basic ratio. We're going to use that basic ratio to help us understand how to create the rest of this. So this is a review of those units 2 and 3. So in order to find equivalent ratios, because that's all a ratio table is a set of equivalent ratios, I am going to look at the multiplicative relationship between my columns. So I'm asking myself, what did I multiply by to go from 2 to 6? Well, 2 times 3 gives me 6. And to keep that balance, to make sure that my my ratios stay equal, that means that I have to multiply by the same number on this side as well. 3 times 3 is 9. Okay. The third part we're actually going to skip for just a second, because you'll notice right now there's no amount of red, there's no amount of yellow. I can't really understand that multiplicative relationship. We're going to talk about that at the end, so I'm just going to put a little star there so I remember to come back to it. But we're going to continue creating this ratio table so that we can look for some ordered pairs. So my next one, I have an 18 in the yellow column. So again, I'm looking at that multiplicative relationship between 3 and 18. 3 times what gives me 18? Well, 3 times 6 gives me 18. That means I have to multiply 2 times 6. 2 times 6 is 12. Okay. My next value is in the red column. So now I'm looking at 2 times what gets me 14. Well, 2 times 7. So that means I have to multiply times 7 over here. So I end up with 3 times 7, which is 21. And lastly, I'm looking at this multiplicative relationship. How do I go from 2 to 16? Well, 2 times 16, or 2 times 8 gives me 16, which means I have to do 3 times 8 over here, which means it's 24. Okay, that's using the information they gave us. Let's go back now to this last one that I put the star next to, and let's talk about that. Because they don't give us a value for either a red paint or a yellow paint, that means I get to make up my own. I get to figure out what am I going to multiply 2 and 3 by to get another value. Now, I don't want to use one I've already done. I don't want to multiply by 3. I've already done that. I don't want to multiply by 6 or by 7 or by 8. I've already done that. But I can choose any other number that's in there. I can multiply by 4. I can multiply by 5. I can multiply by 2. I could even multiply by 10,000 if I wanted. But I want to keep it fairly reasonable. I'm going to say that I am going to multiply that amount by 2. Okay, that means that I, again, am going back to this basic ratio and I'm multiplying by 2. 2 times 2 is 4. 3 times 2 is 6. Okay. Now that I've done that, I'm going to use this table as a way to help me graph it. Now, in order to do that, as you all know, I have to create ordered pairs. Great thing about ratio tables is the ordered pairs are already set up for you. Each row, each individual row is its own ordered pair. Okay, so for instance, this one, I have the ordered pair 2, 3. You'll notice on my graph that cups of red paint is along my x-axis and cups of yellow paint is along my y-axis. So the point 2, 3 means on my x-axis, I'm going to go to 2. Now, if I look at the scale that is on my cups of red paint, it's counting by 4s, okay, which means I'm going to have to do a little bit of thinking and say, okay, well, if it's counting by 4s, that means each line is worth 2. So the first one is 2, 2, 4, then 6, then 8, then 10, etc. Okay, so if I'm looking for the point 2, 3, that means that I go to the very first one on the x value and up to 3, and I'm going to put a dot right there. That's my point 2, 3. My next ordered pairs is the point 6, 9. So I'm going to find 6 on my x-axis, and again, that's kind of between that 4 and 8. 6 on my x-axis up to 9. There's my point. My next one, this was the one that I just made up on my own. So it's okay that I'm going sort of backwards. I'm not progressing forward from the 6. I'm going to go to 4, and I'm going to go to the point 4 and then 6. So I'm going to go point right there. And you'll notice that if there were sort of an invisible line I'm drawing, it falls right in line. Okay. My next set of ordered pairs is 12 and 18. So 12 on my x-axis, 18 on my y-axis. Next row is my next set of coordinate pair, 14 and 21. So 14 up to 21, there's my point. And then my last one, 16 and 24. 16 and 24 puts it right there. Okay. Now, if I were to draw sort of an invisible line between them, or even not an invisible line, if I were to start at the origin and I were just to draw a line that hits all of these points, I could. And the reason you want to draw that line is so that you get that visual understanding of this relationship. I understand that as the amount of red paint moves, so does the amount of yellow. I understand that for every 2 cups of red paint, I get 3 cups of yellow paint, because that's exactly what my graph shows you. Okay, let's look at another situation. Okay, in this one, our ratio table is already filled out for us. So that makes it a little bit easier, but now I'm still graphing from that ratio table. Okay, this particular ratio table is about data that was collected over one afternoon in December in England. You'll notice the very first column, which coordinates with our x-axis, is the time afternoon. So at 0 hours afternoon, that means that it is noon. And then 1 hour afternoon is 1 o'clock. 2 hours afternoon is 2 o'clock, etc. Our temperature, so at noon, at 12 o'clock right here, our temperature is at 5 degrees. At 1 o'clock, our temperature is 3 degrees. 2 o'clock, our temperature is 4 degrees, etc. That temperature lines up with my y-axis. So we're going to use this ratio table to create those ordered pairs and graph them on our graph. Now you'll notice down here at 5 o'clock, all of a sudden our x values go into the negative. So I have to work in more than just the first quadrant. I have to work in now not only quadrant 1, but also be working in quadrant 4, because quadrant 4 gives me those positive x, negative y values. So you'll notice on my graph that's reflected. I can get to those negatives. So again, I'm going to take each individual row and it becomes my coordinate pair. So in the first one, my x value is 0, my y value is 5. Now you'll notice on this, they counted every other line. So 5 is going to go, obviously, directly between 4 and 6. So 0 on the x-axis, 5 on the y. My next one is 1 and 3. 1 on the x-axis, 3 on the y-axis. Next one, 2 and 4. Okay, then 3 and 2. Then 4 and 1. Then 5 and negative 2. 6 and negative 3. 7 and negative 4. 8 and negative 4. Okay. Now, if I were perfect and I could draw a perfect line on this, let's see if I can draw a better line. Okay. If I were to connect all of these points with a line, it would kind of show me a story about what's happening. I can look at that line and say, okay, for the most part, that temperature is going down. Okay, because I start up higher and it continues to go down. Yes, it goes up just slightly between hours 1 and 2, but for the most part, my data is going down. Okay, that also means that I could find another time. I could say, okay, let's say that at 4:30. I wanted to look at exactly what the temperature was. I can use this and say, okay, 4:30 would be right about there on the x-axis. So if I go down, that means the y-axis is sitting right there. It would be about negative 1 degrees, because that's where my line is showing me it would be. Okay. It may not be exactly negative 1 degrees, but it would be very close. Let's go back to our success criteria. With our success criteria, how well did this lesson, 1, remind you how to create a ratio table? 2, show you how to use that ratio table to create ordered pairs. So using those individual rows to create your ordered pairs. And then 3, graph those ordered pairs on that coordinate plane. Okay, we're going to be doing a lot more work with this, not only the rest of this year, but also in future years. So this is important learning for you to hold on to. Okay. As always, if you have questions, if there was something you didn't understand, please contact either myself or Ms. Casperson through email or through Google Chat, or someone come to our live sessions. somehow help yourself as a student and get some help. Enjoy the rest of your day, guys.